And this is, we're going to calculate, eventually we're going to calculate some pH values for these. So we're actually going to figure out what is the pH of this acid or base or whatever solution. Okay? So, here we go. pH, and what does this square brackets mean here, guys? What does square brackets mean? Concentration. So, pH, I'll tell you this right now. pH and H+ concentration go together like peanut butter and jam. They are basically the same thing. No, wait. No, but no, they're the same. That's not a good analogy. They're like, I got it. pH and H+ concentration are like hooded sweatshirts and bunny hugs. Only Saskatchewan people get that joke. All right?
So you're saying that H+ is Saskatchewan?
No. Okay, listen. Okay, let's focus. Hey, you know what? H+ ions don't really exist in water by themselves. So I could also say that, yes? Okay, so make sure we kind of make these little distinctions here. pH, and these are the same things here. Okay, in fact, on the back of your periodic table, you will see concentration of H3O+. Okay, they are the same thing. Remember, it's the H+ added onto water. That's all it is. Same thing. No biggie. Okay, hydrogen ions or hydronium ions are responsible for the acidic properties. Okay, hydronium ions or H+ ions are responsible for acidic properties. pH is less than 7. Yes? Okay? Basically. The greater the H+ concentration, how do you get a greater H+ concentration? Or how do you get more H3O+ concentration? You put more in. Yes? The amount that you put in determines how strong it is, how many moles of that stuff. Okay? The greater the amount, the greater the concentration, the more acidic it's going to be. If you take it straight from the jug yesterday without diluting it, the pH is going to be like -2. Okay? When I gave it to you yesterday, the pH was 3, maybe for the strong one. 2, 3. Yes? Okay? So, I diluted it. I didn't put the same amount in, obviously. I took some amount out. I diluted it. Okay? Even pure water, we talked about this earlier today, has H+ ions and hydroxide ions. Okay? We consider these concentrations to be kind of standard here for water. 1 × 10⁻⁷ moles per liter for those. Okay? Now, we look at acids, and this isn't going to make too much sense for you right now, and you don't really actually have to know this part of it, but it is true that if you have an H+ concentration that is greater than 1 × 10⁻⁷, you're going to have an acid. If you have an H+ concentration that's equal to 1 × 10⁻⁷, well, you're going to have a neutral substance. And if you have a base with an H+ concentration, or H3O+, whatever, that's less than 1 × 10⁻⁷, you'll have a base. Okay? So, like I said, we'll get to that kind of when we start doing the math part on this. Each pH unit, though, does represent a factor of 10. Do you guys know logarithms? Logs. L-O-G, yeah, you know me. Logarithms. No? Some do. Couple do. Logarithms are a base of 10. You will study this in math someday. 10 to a power. Okay? So, what you have to understand is when you have a pH, this is important, when you have a pH of 3, that turns out to be 10 times more acidic than a pH of 4, is what that means. 3 is more acidic than 4, yes? It's lower on the scale. If you have a pH of 3, it's 10 times more acidic than a pH of 4. If you had a pH of 3, that is 10 times 10 100 times more acidic than a pH of 5, 3 to 5. Every time you go up or down on the pH scale, that is a factor of 10. You were either multiplying or dividing by 10, depending on where you're going from. Okay? Each time you go, it is a factor of 10. If you look at this little chart here, okay? Look, anytime I move over, 1, 2, 3, let's say I go there. Every time I do one of those jumps from a pH, I am multiplying by 10, a factor of 10. So, if I had a pH of 6, which is an acid, okay, that's 10 times 10 times 10 times 10. So I guess that would be what? 10, 100, 1,000, 10,000 times stronger. Okay? So it can ramp up pretty quickly. The difference between a pH of 6 and a pH of 2 is a factor of 10,000. Okay? So please know that. It gets 10,000 times more dangerous. Yes? That's a lot, okay, in case you're wondering. How are you going to measure pH? Well, there's a formula that does that, and it's got a logarithm based on it. Okay? So what you're going to do is to find the pH. By the way, on the back of your formula sheet, you will see this. Okay? Same thing, yes? Yes? Okay? So, they mean the same thing. One's, you could say one's Arrhenius definition, one's modified Arrhenius definition. We tend to use the bottom one because it's a little more accurate. When you go to find the pH, you're going to take the negative log of, well, let's do the first one here. You're going to put in brackets. Well, it's already going to have this for you. 1 times 10 to the negative 7, and you're going to close the bracket. That will look like something like this right here. Did I not get it here? There we go. So, when you get your calculator out, this is what you're going to see, right? You're going to go negative. Make sure you use the negative key, not the minus key. You'll get a wrong answer. Negative. Okay? Now, it depends on your calculator. I can't tell you for all these, but this is an 83 plus or an 83. They basically work the same. 84, roughly the same. Negative. Log is right here, right beside the 7 key. Log. Okay? You'll type in your concentration. 1 times 10 to the negative, don't forget, 7. And you can close the bracket like so. And you're going to hit enter. Okay? And that'll change it from a concentration to a pH value. And if you had this concentration, you would basically find out that in fact this is a neutral substance called 7. Okay? So, we put a 7 there. pH is 7. As far as, I need to get this done before you go any farther. Look up here, guys. As far as significant digits go, you guys, most of you don't know much about logarithms, and that's okay. You just have to follow this rule for me here. How many significant digits are in this concentration right here? How many do you see there? How many significant digits are there? This is not a trick. The answer is 2. If you have 2 in the concentration, and this always goes, this is how it works. 2 here means that you have 2 after the decimal here. Those 2 represent those 2 after the decimal. That's how it works. And it's the same when we go backwards tomorrow. Okay? So, I'm going to save a little bit of time here. Look, this is going to be 3. 2 significant digits, 3.00. I want to see. Okay? The next one is 11, is what you're going to get from typing this in. Those don't count. Okay? I still need 2, so I put in 0, 0. 2 there, 2 after the decimal. Okay? All right? You have to remember that. 6 is only 1 here. So when you do this one, by the way, the easy stuff's off. You actually have to do this on your calculator. It doesn't work out like that anymore. So when you type in negative log of 6 times 10 to the negative 8, you get 7.22. Okay? 1, look, don't pack up yet. 1. 1 after the decimal. Okay? You guys can go ahead and fill in the rest there on your own. Okay? So you have to remember that. That's very important. Tomorrow, we're going to flip them back the other way, and we'll start doing some math problems with these.